Item 3. G of theta equals 4 times the cosine of 2 theta plus 2 times the sine of 2 theta. Given that g of theta equals r cosine of 2 theta minus alpha, where r is greater than 0 and 0 is less than alpha is less than 90 degrees. Part A. Find the exact value of r and the value of alpha to 2 decimal places. Part B. Hence, solve for negative 90 degrees is less than theta is less than positive 90 degrees for 4 cosine of 2 theta plus 2 sine of 2 theta equals 1, giving your answers to 1 decimal place. Given that k is a constant and the equation g of theta equals k has no solutions, state the range of possible values of k. So now for part A, we need to remember what we have been given. This is that g of theta equals 4 cosine of 2 theta plus 2 sine of 2 theta, and that g of theta equals r cosine of 2 theta minus alpha. We want to find the exact value of r and alpha to 2 decimal places. That means that we have the equation 4 cosine of 2 theta plus 2 sine of 2 theta equals r times the cosine of 2 theta minus alpha, because we know that g of theta equals both of these. Now, this is what is called a harmonic identity. The formula for this harmonic identity is a cosine of x plus b sine of x equals r cosine of x minus alpha. And the value of r is equal to the square root of a squared plus b squared. And the value of alpha is the inverse tangent of b divided by a. So we solve. A and b are 4 and 2 respectively. So r equals the square root of 4 squared plus 2 squared. This is the square root of 20, which you could also simplify to 2 square root to 5. Now, alpha equals the tangent of negative 1, or the inverse tangent of b divided by a. So that's the inverse tangent of 2/4, which is the same as 1/2. And that's approximately 26.57 degrees. Remember, you're rounding this to 2 decimal places. Part B. Now we want to solve this for negative 90 degrees less than theta less than 90 degrees. And this time we have 4 cosine of 2 theta plus the sine of 2 theta equals 1. And we want this to be to 1 decimal place. Now remember, we can do something to make this easier. We know that 4 cosine of 2 theta plus sine of 2 theta equals r cosine of 2 theta minus alpha. And we also know the value of r and alpha that we found in part A. So we can rewrite this as the square root of 20 times cosine of 2 theta minus 26.57 equals 1. We divide both sides by the square root of 20. Then we take the inverse cosine. Now remember, when we take the inverse cosine, we're going to get 77.1. But look, we want our graph to be between positive 90 and negative 90 degrees. That means we also need to consider negative 77.1 degrees. So we will solve then by adding 26.57 to both sides, and then we will divide by 2 to get 51.8 degrees, and on the other side we perform similar steps to find out that theta is about negative 25.3 degrees. Part C. K is a constant, and the equation g of theta equals k has no solutions. we want to know the possible values of k. Now you know that our g of theta is a graph of cosine and sine. So its graph will look something like this one. The graph has maximum and minimum values. We know what this is. It's the square root of 20 and the negative square root of 20, because that's the r value that we already found. Any value bigger than the square root of 20 will not be in the range of this graph, and any value smaller than the negative square root of 20 will not be in the range of this graph. So the possible values for k are k greater than the square root of 20 and k less than the square root of 20.